Okay, hi everyone, and welcome to the NUPOC video study guide number 89. Let's start taking a look at some pulley problems, which are really just they're just physics problems. You know, we're going to use Newton's second law a lot of the time. We're going to sum forces at each of these pulleys and all that good stuff. And the pulley problems we're going to do are going to fall into a couple different categories. Basically, they're either going to be statics problems or dynamics problems. That is, they're either going to not have any acceleration, which is the case here, and there'll be a statics problems. There'll be a static problem, and we'll go ahead and sum all the forces and set them equal to 0. And then in some other problems, there'll be dynamics problems, so there will be some acceleration, and we'll sum the forces and set them equal to mass times acceleration. So let's go ahead and start with this problem here, which is fairly basic. We've got these two pulleys, and let's call this pulley 1 and this one pulley 2. And pulley 1 is anchored to the ceiling here, and pulley 2 has this mass M hanging off of it, and our rope here kind of weaves through the two pulleys, and we're pulling down on the rope on this side with force Ft. And that stands for the tension force in the rope. Okay, so the first thing to remember with pulley problems is that we assume that the rope, or the line, or whatever you want to call it, is inextensible, so it doesn't stretch, obviously, and it's massless, and we also assume the pulleys themselves are massless and frictionless and all of those good things. And we also need to understand that the tension force, Ft, in this problem, is the same all along the rope. So if I cut the rope, no matter where I cut the rope, that force at that cut will be the exact same. So if I cut the rope here, not literally if I cut it, but if I were to observe the rope here, there would be a tension force, Ft, pulling in both directions here, right? And we'll use that when we analyze individual sections of the pulley problem. So the first thing we're going to do is we're going to look at the mass here. And this is a statics problem because while this block is rising, it's rising with constant velocity v. There's no acceleration. So let's take a look at mass m first, and we'll draw our good old free body diagram, right? So we have mg pulling down, and pulling up, we're going to have, I'm just going to call it fx, right? That's pulling up on this little connection here, right? Okay, now let's go ahead and if we now sum the forces in the y direction, let's of course remember to draw our coordinate system here, right? This is y hat, x hat, and right hand rule, this is z hat. So in the x direction, right, we have fx equals mg. Okay, now let's take a look at pulley number 2 here. So we have pulley 2, and of course we have fx pulling down there, and here we have ft, the tension force in the rope, because I've sort of cut the rope here and again here. And I have another tension force here in the rope, Ft. So here I actually have, if I sum the forces in the y direction, I guess maybe I should have chosen this to be Fy, but you know what? That's okay. This is Fx, and even though it's moving in the y direction, and I'm not going to bother changing my coordinate system, so we'll just keep going. So here we have 2Ft equals Fx, and then we can use this equation and just say equals mg. Okay, now let's go ahead and we can in fact just solve the problem right here without even considering this second pulley here, or well, the first pulley here, pulley number 1, because now we can just say that Ft, let's just write it right here, Ft equals mg over 2. So if we're looking for Ft in terms of that mass, the force required to raise that mass at a constant velocity, then we have it. Now if we wanted to do something where we had to analyze pulley 1, that would be if maybe we wanted to look at what the force is in this connection right here. And maybe let's call that Fy. Okay. And let's call this force, remember we call that Fx. Just want to make sure we write it on the diagram. So now if we look at pulley 1, right, we have Fy pulling it up, and we have 2 Ft's pulling it down. So from this, we could say Fy equals 2 Ft, right? So that means it equals Fx, but of course in a more meaningful way, let's write, we know Ft equals mg over 2, so it just equals mg. So we could also say that Fy equals Fx equals mg. Right? So that's pretty cool. The force in these two connections here, the anchoring connection to the ceiling and the connection from the center of pulley 2 to the mass, have a full load of mg, but the tension in the rope is only half that. It's only mg over 2. So that's pretty neat. Well, anyways, thanks for watching, and as always, don't forget to click this button right down here and subscribe so you don't miss any of the upcoming videos.